Hi there. In this video we're going to talk about the law of cosines. So the law of cosines comes in very handy when you're trying to find all the sides and angle of any type of triangle. So we're going to hopefully prove this in class, or you I should say will hopefully prove this in class. But really what it comes down to is that we can think of the Pythagorean theorem, right, where we have the sides of the triangle A, B, and C, except we're going to have to adjust the Pythagorean theorem a little bit since this isn't necessarily a right triangle. And also notice that I labeled the side across from angle A with a lowercase a, and the same for B and C. So here's the law of cosines. A side of the triangle squared, I'm going to say A squared, is equal to one of the other sides squared plus the square of the third side. So far we have the Pythagorean theorem pretty much, and here comes the adjustment. Minus 2bc times the cosine of angle A. So since this is solving for side A, right, and we kind of just chose A arbitrarily, we could also say that there are two other law of cosine formulas, right? So I could say, well, side B, I could find that by saying B squared equals A squared plus C squared, right? That's the sum of the other two sides squared, minus 2, in this case we're going to use those other two sides, so 2 times AC, and this time we're going to use cos of angle B. So by now I hope you're seeing the pattern. Right, we could also say that C squared equals A squared plus B squared minus 2AB cos of angle C. Right, so it really is the same thing, it's just the three different perspectives. So in these problems, we're going to ask you to solve a triangle, and what that means is that we want all three side lengths and all three angle measures. So I'm just going to put a little chart down here to kind of fill in what we know and don't know. So A, B, and C, those are going to be our side lengths, and let's do angle A, B, and C over here. So I know I'm done when I find those 6 things. Okay, so let's fill in what we know. We know angle A is 40 degrees. Side C is 10. And side B is 8. Now look at your situation here. You know a side, angle, side. Right? And that angle is nestled between those two sides. Remember when we used to prove those triangles congruent? Right, this would be a case of side, angle, side. So in this situation, it's a nice kind of signal that we could use cosine to solve the triangle. So let's see, we really need to find side A. That's what's missing. So we know that A squared equals B squared plus C squared minus 2BC cos A. So let's fill in B and C. B was 8, C is 10, and angle A is 40 degrees. Okay, so our job is to solve for A, so I just have a bunch of calculations to do. I'm going to try not to use my calculator until I absolutely have to. Let's see, we have a 64 plus a 100, that's 164. Let's do the multiplication over here. That's 160 times cos of 40 degrees. Okay, so now if I want to find A, I'm going to have to square root that entire value. And obviously I don't need the negative of that. A is an actual distance. Okay, and I have a degree, so I'm going to go to my calculator now. And my calculator is going to be in degree mode. And I want the square root of 164 minus 160 cos of 40 degrees. So So I get 6.437. So we can fill that in right there. Okay, now we need to find angles B and C. So I think we have a choice. Since we know the side across from the angle, we actually could use law of sines, or we could keep using law of cosines. It's really up to us. So let's see. I'm a big fan of law of sines, so actually I'm going to use that. So let's say sine of angle A, in this case 40 degrees, over side A, which is 6.437. That's going to be the same as the sine of angle B over side B, which is 8. So let's solve for B. So I get 6.437 times the sine of B equals 8 sine 40. And again, I'm not going to use my calculator until I absolutely have to. Let's divide both sides by the 6.437. So I get sine B equals 8 sine 40 degrees over the 6.437. And to find B, I'm going to have to take the inverse of that. I should say the sine inverse of that. Now I can say that that's actually what B is. So let's type that in the calculator. So sine inverse of 8 sine 40 degrees divided by 6.437. And I'm getting angle B to be 53.022 degrees. So we'll fill that in over here. Okay, and then to get angle C, we know that the three angles in a triangle have to add up to 180. So let's just do angle C is 180 minus 40 minus 53.022. So I get 86.978 degrees. Excellent. So now we found all 6 parts of that triangle. So in this example, we're going to solve triangle ABC, but this time we know all of the sides. So I would say that this is an SSS case. So let's write down what we know and what we don't know. We don't know the angles, but we do know the 3 sides. And those are A being 12, B is 8, and C is 7. Okay, so let's think about this. If we want to find an angle, we're going to have to choose a side across from that angle and start there. So I'm going to start with finding angle A. So the side across would be 12, so 12 squared equals 8 squared plus 7 squared. Here comes that adjustment. Minus 2 times 8 times 7 cos of angle A, the side across from, or sorry, the angle across from 12. Okay, so let's simplify. We get 144 equals 113 minus 112 cos A. Okay, don't make a common mistake, and that would be to subtract the 113 and the 112, but you can't do that, right, because the 112 is being multiplied with the cos A, and multiplication happens before subtraction. So instead, I'm going to subtract 113 from each side. That leaves us with 31 here, equals negative 112 cos A. Wonderful, so now let's divide by negative 112. And it's time to take the cos inverse of our negative 31 over 112, and that will give us angle A. And I got angle A to be 106.068 degrees. Alright, so we definitely have an angle for A. Now think about how you want to get an angle for B, or C, right? Doesn't matter which one. We have everything set up for law of sines if we want to do that. We could also use law of cosines again. Let me use it again just so we can practice it. Okay, so let's say I'm looking for angle B. I'm going to start with the side B. So 8 squared equals 12 squared plus 7 squared minus 2 times 12 times 7 times the cosine of angle B. Okay, now it's time to just simplify and do calculations. So let's see, 12 squared plus 7 squared is 193, and 2 times 12 times 7 is 168. I'm going to start getting the cos B by itself, so subtracting the 193. And now dividing by negative 168. That becomes positive 129 over 168. So now the cos inverse of that value is what angle B is going to be. And I get that to be 39.838 degrees. So I'll fill that in. And then to find that third angle, we know that the three angles have to add up to 180. So I'm doing 180 minus 106.068 minus 39.838. And I get 34.094 degrees. Alright, so here's another example in which we actually didn't get two answers for the angles, right? Because when I take cos inverse, I'm really going to get only one answer in my calculator, but think about what quadrant that was in. That was in the first quadrant. That's where cosine's positive. The other place where cosine is positive is in the fourth quadrant, right? And that's too big. So in the next video, you will see some examples of what we call the ambiguous case, where we actually can get two possible triangles with the given information.